Welcome to section 7.8. This section is entitled the addition rule. And so I have that written here, but I also have or better stated or probability. When they talk about the addition rule, they are talking about a very specific question that's going to be asked, and that is what's the probability that one thing happens or another thing happens? And when that happens, you're basically adding up all the different responses that make it true. And we'll watch this happen in just a moment. The reason why I want you to understand that it's or probability is because they make it sound very formulaic, but it doesn't have to be. I want it to be visual as opposed to formula driven. So if you were to read the textbook, they would have a formula that looks like this. The probability of A or B is equal to the probability of A plus the probability of B, hence the addition rule. But the strange thing, it's not super strange, but then they have to talk about taking out the probability that A happens and B happens at the same time. We don't have to think about that. And so we're going to focus not on a formula, but on understanding and answer questions based upon understanding. So I don't want you to think about that formula that I just gave you or the one that you'll read in the book. I want us to focus on the question because or probability is very intuitive. So you've been through 7.5, especially where you're finding the probabilities of certain situations by looking at the sample space and identifying, okay, how much is in that simple sample space? That's my denominator. How much meet my criteria? That's my numerator. And then we're pretty much done. So for example, we did something where we rolled a die. So let's roll, I'll keep it positive here. Let's roll a single 6-sided die. And let's range through some sections that we've covered, focusing on probability so that it stays fluid. In 7.4, they asked us what the sample space was. And we said, no problem. When I roll that die, here's what could come out. A 1, a 2, a 3, a 4, a 5, or a 6. That's my sample space, those 6 individual things. That's also the simple sample space because that's the only way for these things to come out. So there's only one number 1 on the die, one number 2, so forth and so on. So that's 7.4, hey, that's my sample space. In 7.5, they said something like this, hey, what's the probability that you roll 6? And we would say, okay, I know what that is. I need to count the number of ways that I can get a 6. Well, it looks like there's just one way to get a 6. Out of the total number of outcomes, well, there's 6 outcomes, right? 1, 2, 3, 4, 5, 6. One of which is 6, so we get 1 out of 6. They stepped it up and said, hey, what's the probability that you roll maybe a multiple of 3? Okay, so let me come in here with my eraser, new question, but same sample space. I'd look at my sample space and I would say, well, what meets my criteria? Well, 3 is a multiple of 3, 6 is a multiple of 3, and so I'm finding that 2 out of the 6 answers are a multiple of 3. That's the probability that I roll a 3. We know that I'm happy with the 2 over 6, but the back of the book is going to reduce that down to 1/3. And that's where we've been. So what changes as we go up here and come to a new section, and they ask us, hey, what's the probability? So now we are in section 7.8, and they're going to ask us, hey, what's the probability that we roll either a 6, oh, no, actually, let me not start that way. I can start a 6 or a 2. And so we say, okay, I can handle that. We look at the sample space, which is still visual on the screen. So the sample space is right up top here. I'm going to make this look more like a parenthesis rather than a bracket. What's the probability to roll either a 2 or a 6? So I'm going to do something very deliberate here, and it's going to maybe seem overkill, but eventually it won't be. So we're interested in rolling a 6. As I go up to my sample space, which is towards the top of the screen, there's 1 6 or a 2. And so the second ask is a 2, and I realize there's 1, 2. So the probability that I roll either a 6 or a 2, well, there's 6 possible outcomes, and only 2 of which I'll be successful on. So again, it's 2 out of 6 or 1/3, but for a completely different reason. So there's no real formula to use there. It really just is, okay, what do they want? What's going to be a success for me? How many times is that happening overall? So let's go a little bit deeper. We'll practice one more time with something that I think is simple. Roll 2 or a 5. And if I roll a 2 or a 5, I'm going to come back up here, get rid of these markers. I'm looking at this new setting again. I can roll either a 2 or a 5. So first thing I would recommend is look for all your 2s. There's only one of them. Then I would look for all the 5s. There's only one of them. So again, it's 2 out of 6. And that's our answer for that one. So you think, well, this is pretty simple. And it does stay simple. How about this? Roll an even number or a multiple of 3. Okay. Roll an even number or a multiple of 3. So I'm going to come down here and I'm going to redraw my sample space so that we don't have to go up here. So I know I'm rolling a single die. So I roll the die and I could get any one of these 6 outcomes. So I already know that the answer to my question has a 6 on the bottom to start out with. Now, it's going to be an even number. So my even numbers are 2, 4, 6. So I at least have 3 things that I'm going to be accounting for. But do I get anything else with the second condition? The second condition was a multiple of 3. Now, as I look at this list, there's 2 multiples of 3. I'm going to point to them, 3 and 6. Now, you're looking for any number that you haven't chosen that meets that second criteria. So you already have 2, 4, and 6 circled, and you're asking yourself, are there any other multiples of 3? And there is. So notice that 6 is also a multiple of 3, but I don't want to double count it. That would give a false impression. 6 is even. 6 is a multiple of 3. We don't want to double count it. If you remember that formula that I briefly put up in the beginning, that's what the subtraction was. The subtraction was going to get rid of that overlap. But if we have the presence of mind to ask ourselves the question, when we go to do that second thing, the question wasn't how many multiples of 3 are there. Here's the question. The question when we go to this second one is, are there any other outcomes that are multiples of 3? And in this case, there's 1, that blue 3 that's circled there. Again, we know 6 is a multiple of 3, but we've already counted it. So if we look at the numbers we had circled, there's 1, 2, 3, 4 right answers out of 6. And so the answer is 4/6, or 2/3, as the back of the book would have it. So I hope this is making sense so far. Let's keep looking at examples and start to mirror the examples that are in the book. So as you start the homework, it's going to have an example where you have a 6-sided die with both numbers and letters. And so as I look at an example, they're going to say, roll a 6-sided die with sides 1A, 1B, 2A, 2B, 3A, 4E. Let's just make that up right there. So there's my 6 sides. If you remember these questions from 7.5 and 7.4, really, where we're listing out sample spaces, we'd have a space like this. And they can ask this question. What's the probability that when you roll this die, you get an even number or a vowel. Okay. And what I want you to think about again is that we have our first criteria, even number. We have our second criteria, vowel. So as we go in here and think about our first criteria, even number, just circle all the even numbers. If it's an even number, we're going to take it because that's a success for us regardless of the letter. So I have 2A, 2B, 4E. Now, A and E are vowels, but that doesn't matter to us because we're focused on an even number. B is not a vowel. Again, that doesn't matter to us because we're focused on the fact that we got an even number. That side of the die is successful because of the red criteria. We're going to be happy if we get an even number. Or it could also be a vowel and we'll be very happy. So the question then is there anything that's not circled that's also a vowel? And so this 1A is a vowel and 3A is a vowel. The only thing that wasn't circled in red that wasn't a vowel was the B. And so we see very clearly that the answer to our question is 5 out of the 6 meet their criteria of either being an even number on the side or a vowel on the side. Some of them have both. That's okay. But all of them have at least one of those, and that's what we want. So pretty nice. So you're going to have that whole first section like that. Then they're going to turn to a situation like, well, they're going to turn to cards. Sorry for the hesitation there. They're going to turn to the cards, and we have our 52 card deck. And hopefully you're familiar with that 52 card deck here, but I'm not going to assume that. I want everything to be as visual as possible. So remember what we have. We have hearts, right, which they use the heart symbol. We have diamonds, which they use the diamond symbol. They have spades. It's that upside down, I'll try my best to do it, upside down heart. And they have clubs, right? And we know within each one of those suits is the numbers 2, 3, 4, 5, 6, 7, 8, 9, 10, Jack, Queen, King, Ace. And diamonds also has a 2, 3, 4, 5, 6, 7, 8, 9, 10, Jack, Queen, King, Ace. 2, 3, 4, 5. So I'm doing this right now, and you can think, well, this is a waste of time. I'm doing it so that we can all have the same perspective, that we can see that it's visual. If you already have this in your mind or understand cards very well, then you don't have to write this down. If you're hesitant at all, I would suggest writing it down because what just happened took seconds in order to come across and make that look a little bit better, hopefully. Okay, it's this upside down heart thing with this little stick coming out. So we have the hearts, diamonds, clubs, spades, and clubs, and the 13 cards in each. And they're going to ask a question like this. If you choose a card at random, so it's still just one choice, find the probability that, and they're just going to ask you questions. Hey, find the probability that it is a king or a queen. Awesome. This time I'll use a highlighter. So how about the king? Well, I got 4 kings, right? 1 in each suit, right? If I come back up here, I got those 4 kings. Or a queen. What about the queen? I got 1, 2, 3, 4 queens. Notice there's no overlap between those two. There's no places where they coincide. There's no double counting possible. I didn't have to, all the queens were unshaded once I got that king. That's going to happen sometimes when the events are mutually exclusive, when they can't happen at the same time. I can't pick up a card that's both a king and a queen. And so when that happens, I realize, oh, there's 52 cards, 4 of which are kings, plus 4 of which are queens. That's a total of 8 out of the 52. and our book would reduce. I think dividing by 4 would be possible, and we would get 2/13 as our answer. Again, either answer is acceptable, but again, or probability is not bad. We're just counting up all the successful outcomes. So then they could ask a different question, like the probability that you get something like a 6 or clubs. Okay, so 6 or clubs. Again, you already know your bottom number is 52. Let me use my eraser. And this time I'm going to circle. And so let's go get our 6. Okay, I'm going to circle everything that's a 6. 1, 2, 3, 4. There's 4 6s. We knew that already. Do you remember how many clubs there are? Yeah, in each suit there's 13, so there's 13 clubs. But our answer is not going to be 4 plus 13. Here's the reason why. We're going to be very careful. So we go here and we're interested in clubs. Now clubs is this last column. So the question really is there anything I haven't circled yet, already counted, that's a club? And yes, there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 cards that have not been circled. Not 13, because we've already counted the 6 of clubs. We don't want to double count it. So our circles should look something like that. I can literally add up my circles. 13, 14, 15, 16, right? And say, hey, the answer is 16 out of 52. 1, 2, 3, 4. 1, 2, 3. So we could do 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 4 plus 12, yeah, that's 16. However you want to do it, but you can make it completely visual and be able to answer the questions. And so what do we get out of this? 16 over 52, certainly both divisible by 4, and so we get 8/13 out of that. Oh, apologize, not 8/13. I divided one by 2 and the other by 4. We get 4/13 out of that. Okay, so apologize for that mistake there. But hopefully you see the 16 out of 32. You're going to have a block of problems that look just like that. Then they're going to give you this little table here that shows you majors that students have and whether they're freshmen, sophomore, junior, seniors. What's important to note every time you get a table is you want to make sure you understand the information. So if I look at the number 138, I don't know if that's right here by my cursor there. I didn't realize it would let me go in and type there. But this 138 that's right up here, what is that? Those are 138 first year or freshmen are majoring in art, are arts majors. This 539 way down here is the total number of art majors there are. This 1,117 right below it is the total number of humanities. 2,974 that's down here is the total of everyone that they talk to. So everyone in this school totals 2,974. So they could ask a question like this. What's the probability that you randomly select a student? So maybe I should write that. I apologize. If a student is randomly selected, find the probability that they are, and they'll say A, either a sophomore or senior. Well, let's go do that. The probability that they're either a sophomore or senior is equal to, well, how many sophomores are there? Looks like there's 770 sophomores, right? The 121 art majors, the 301 humanities, of 151 social science, and the 197 natural science total up to be 770. How many seniors are there? In that same row, we see that there's 735 seniors. Now, you can't be a sophomore and a senior, so there's no overlap at all, so it's just a straight adding of those two. Here we're not counting up circles because there's just so many. Do you happen to know what our bottom number is? Our bottom number should be the total number of students, which it tells us is 2,974. So we're almost done. We just have to grab our calculators and add 770 and 735 and come up with 1505 out of 2,974. That's a fine answer, right? You could also, if you wanted to, reduce that fraction if it does reduce. Not sure if it does. A little bit tricky there. Or you could express it as a decimal, but this is a perfectly fine answer because we can see it. What about something like this? The probability that they're a sophomore or an arts major. Well, how would I do that? The first thing that I would do is I would say to myself, okay, what's the first thing that they asked for? The first thing that they asked for is being a sophomore. So I go up here and realize, well, I already know there's 770 sophomores. And perfect. So I come down here and say that there is, let me kick that off, that there's 770. Same 770 that I had before. Then I realize that the second thing they asked for is arts majors. So I'm up here trying to identify arts majors. And not sure where my 770 went away, but I'll put it back in there. Must have just inadvertently erased over it. But I'm in that sophomore row and looking, I'm in the arts row, and I realize there's 138 and 148 and 132 that I have not accounted for yet. And so that's what I need to add in there. Hey, there are, and let me put it in red if it lets me. It's already in red. So there's 138 first year arts majors. I've already counted the 121. So I don't want to count the 121 again, but I need to count the 148 that are juniors and the 132 that are seniors. So hopefully you're seeing what I'm seeing. I'm in that first row saying, okay, I'm interested in getting arts majors. There's 138 first years. There's 121 sophomores, but I've already counted them, right? And so I don't want to double count them. So I get the 148 juniors and the 132 seniors. Remember, the 539 is the total arts majors. I don't want to use that because there's some overlap there. There is a way to use that, but you'd have to subtract out the double counting of the sophomores, which is a fine way to go about it. And so here, remember, this is still over 2974. So what do I get? I get 1188 over 2974. So it really is just looking at this and not sure if it will allow me to do this, but you got this whole row. Yeah, it's treating this like a text area, so it's not going to let me circle it. But you have that whole first row and this column right here. And the trick is not to double count the 121. When I wrote down the 770, it included the 121 art majors that are here. What I didn't have is these 138s, these 148s, and this 132, so I added them on. Hopefully that makes sense to you. This is the idea in this section, is to look at your sample space, read the question, say, okay, I need to have a 6 or a club. Cool, let me get all the 6s. Those are the red 6s. Let me circle any additional clubs. Great. Let me count all those. Awesome, that's 16. How many were present? 52. Oh, my answer is 16 out of 52. And it can feel just like that. Not formulaic, but understanding. That's what we would love. So hopefully this resonates with you and allows you to be super successful in the 7-8 homework. Thank you for